In this video I decided to try to program an entire solar system simulation using Unreal Engine 5 in only 1 week. And let me tell you, I couldn't be more happy with the end result. So why a solar system simulation? Well, space has always been a mysterious place to me, and not too long ago I had a physics test about the solar system. And I found it very fascinating how everything could be explained with just a couple formulas. That made me wonder how hard it would be to make my own simulation of a solar system. However, at this point in time I was still learning OpenGL, so I decided to put that idea away for a bit until I was more confident in my OpenGL skills. Now that I finally decided to stop torturing myself and started using an actual game engine, I wanted to come back to that idea. And because I normally make my projects way bigger than necessary, I am giving myself the 1 week time limit, so this video won't take years to complete. So let me give you a quick overview of what I have in mind. I will start by making a C++ class called Planet. It will include a couple of public variables like mass, radius, starting velocity, etc. that I can specify for each planet. I also want to have a solar system class with a list of all planets in that solar system. In the update function of the solar system class, I want to calculate the force applied to each planet from all other planets and then add it together. In the update function of the planet class, I want to calculate the movement of the planet. And lastly, I want to be able to see the orbits of each planet in the editor. How we'll do all this I will explain later, but for now let's start at the beginning. I created a new C++ project and started by creating a planet class. I opened it up and I completely forgot how to use C++ for Unreal Engine. But I mean, I only used it once during a tutorial a couple of months ago, so I can't really blame myself. So instead of watching a 10-minute video and pretending I know it all like I did before, this time I will watch 4 10-minute videos and pretend I know it all. I mean, that's already a massive improvement. So I once again created a new C++ project, or at least I tried to, because I forgot I couldn't press the create button while I was recording because my recording software is in the way. But then I figured out my recording software allowed me to draw on the screen and I got way too distracted. But after that I finally created a project and started learning. So it honestly wasn't even that bad. I already know C++ pretty well, so the only things I really had to learn were the additional Unreal Engine rules, like having to put uProperty in front of each variable and uFunction in front of each function, with some values that determine how they behave. Of course, there are some more things that are specific with C++ for Unreal Engine that have to do with like interaction with the game world, but we'll figure those out as we go. The only thing that got me mad a couple of times was Visual Studio and Unreal Engine just not being able to work with each other, and Unreal Engine having to compile the code for a minute each time I make a small adjustment. But other than that, it was pretty doable. Anyways, now I can finally create a new project one final time, create an empty level, create a Planet C++ class, and start the actual coding. So in the Planet class we have a couple of variables, like I said before, and the tick function, which we'll use to update the positions of the planets. But to actually calculate how much a planet should move, we need to calculate the force. To do that, we'll make the solar system class that will keep track of all the planets in the solar system and calculate how much force they receive from each other, just like I said before. I will now try to explain the physics behind it as best as I can, so if you're not interested in my nerdy talk, skip to the following timestamp. Alright, let's talk physics. We will be using the formula for gravitational force, which is this fun little thing. It is used to calculate the force that one object receives from a different object. In our case, the force that one planet receives from another planet. But because of Newton's third law, the amount of force one planet receives from another is the same amount of force as the other player receives from this planet. So, what do all these letters mean in this formula? Well, the g is a constant value, which in the real world is this small number. But we will use a number that is a lot higher than this. So it doesn't actually take a year for a planet to make a full rotation. These two m's are the masses of the two planets we want to calculate the force between. The r is the distance between the planets. And this weird looking r is a three-dimensional vector that represents the direction that the object should be moving. So in our case it will be the direction of the other planet. And lastly, this minus just makes sure that the force we are calculating is how much a planet is attracted towards another planet. This equation gives us a vector with a direction and a force amount. We will pick one planet and use this calculation to calculate the force it receives from all other planets. If we then add all of these vectors together, we will end up with one vector that is the resulting force of the planet. Then we use Newton's second law to calculate the acceleration of the planet. And lastly, we just add the acceleration to the velocity and calculate the new position of the planet. We just repeat that for each of the planets in our solar system and boom, we got it working. So, nerdy talk done, let's now actually code it. So I basically just started coding exactly what I just described. It wasn't that hard, but I'm still very new to the entire Unreal Engine C++ stuff, and I just suck at programming in general, so it took me a while to figure everything out. Like, at some point I was just trying to fix this error for about 20 minutes before I realized that it wasn't an actual error, I just had to recompile the code. But after a while I got the solar system class set up with a function that calculates the force of each planet, and the planet class with the position calculations. However, to actually be able to view if the code was working, I had to make a visual representation of the planet. So I wanted to give the planet class a sphere mesh and then update the size of the mesh using the radius variable. Well, remember when I said, of course there are some more things that are specific with C++ for Unreal Engine, but we'll figure those out as we go. Yeah, this was one of them. But after crashing Unreal Engine a couple of times, I managed to get it to work. The only issue is that you can't really see it, because it's just too dark. So next up I used my knowledge about materials that I gained in the previous video and made a planet material that emitted light. Then my PC black screened and I had to remake the entire planet material once again. But it was all worth it in the end because now I can actually see the planets. I created one small and one big planet and gave the small planet a bit of starting velocity. Let's see if it works now.
Bye, have a great time.
I mean, it's alright, it never really works 100% on the first time, right? But that is a quick fix. And after tweaking some values I ended up with this, which showed me that it was properly working, which was pretty surprising because normally it never works this fast. Well, apparently Epic Games didn't really like that I got everything working this fast, because I quickly got reminded why I haven't used game engines until now. I booted up the project the next morning, excited to continue the project. I hit play just to get the little satisfaction of everything working how I wanted it to, and it just didn't do anything. It still said it calculated the acceleration the right way, but it just didn't get applied to the velocity. I rebooted Unreal Engine a couple of times, rebuilt the code, tried everything Reddit could throw at me, but nothing seemed to work. I started tinkering with the code a bit just to see if I could find the issue, and I found out that it was all because of this delta time variable. The delta time variable makes sure that the program runs the same on each computer instead of the planets going extremely fast on good computers and extremely slow on bad computers. When I removed it, it actually seemed to work, but I just couldn't figure out why it was suddenly not working while it was fine yesterday. After some time, I still couldn't get it to work properly, so I left my PC for a bit, and when I returned, Unreal Engine didn't even want to boot up, so I knew something was really wrong. So I deleted Unreal Engine and reinstalled it, which took multiple hours, but after booting up the project again, everything works properly. But the day was already over. Now that everything is working again, the time has finally come to get the orbits working. My plan was to have a button that when pressed simulates the movement of the planets without actually moving the planets, and saving the position after every calculation. On some of those points it will then place a dot so the orbit will be visible. But I came to the conclusion that the way I set up my code was a complete disaster to achieve this, and I caught myself having coded in a lazy way, which means it was very hard to implement any new functionality. Because of that, I first had to program everything in a proper way. After doing that, I could finally start the programming of the orbits. I coded a function that calculated the orbit points, where I could pass in the number of points I wanted to see and how much time is between the points. Now I just click create orbit and yeah, well, that was about as well as I expected it to go. After fixing that issue, it actually worked pretty well, but I realized that when I spaced the points out a lot, it won't calculate the movement properly if the planets are close to each other. So for now I just calculate the points very close to each other, but I will fix that later. It took me a while to get the orbit to calculate in the right way, because of the fact that the FPS between computers can vary, and even though you have the delta time properly, when you make hundreds of calculations each second, which is the case in most simulations, it will almost always have some inconsistencies. Because of that, I had to use a few tricks and I now got it almost perfect. It was now time to add another planet. Alright, orbit is looking good. Alright, well that should be a quick fix. Oh no, not this again. So yeah, everything broke after I added another planet, but that was just because I made a whole lot of dumb mistakes while recoding everything. And looking back at it now, I'm actually pretty embarrassed that I even made these mistakes. But oh well, I ended up using the entire day fixing it, but now I have a rock solid foundation that actually does everything well. So in the next 2 days I spent a lot of hours optimizing everything. Because even though I didn't show it yet, every time I wanted to create the orbit, I first had to delete the previous orbit, which took a minute, and then create the orbit again, which took another minute. And my PC wasn't really sounding too happy when I did all this. So I wanted to optimize this a lot. And also it didn't really look all too good, so that's also a thing I wanted to fix. I didn't really record a lot in these 2 days because it was very boring, and that it took me this long was only because I had to research a lot of things that I just didn't know about in Unreal Engine. But at the end of day 6 I could throw down a couple of planets, add them to the solar system, create an orbit in a couple of seconds, change the positions of planet and instantly generate the new orbits. I am incredibly happy with what I have achieved so far because it looks very cool and it works like I wanted it to. The orbit also consists of 1000 points for each one, and my computer is handling them fantastically. So for the final day I just wanted to make everything look good and make a small cinematic video of the simulation. I started by browsing on multiple platforms for good looking planet textures, but I couldn't really find a lot on the usual sites. But eventually I found this website that has high quality textures of the planets in our solar system, so I decided to borrow them. I also found this image of the Milky Way that I wanted to try and put as a skybox of the project. I started by applying a couple of these textures on the planets and I tried to add the Milky Way image to the skybox. But it just didn't really look right, so I ended up creating my own skybox in this program called Spacescape with just some basic stars. But now I had the problem of the planets not being visible when I hit the play button, because there was no light. So of course I had to add a light, and this was gonna be inside of the sun. However, doing that resulted in the sun not being visible, so I just added a bit of emitting light to the sun material and accepted the fact that you couldn't really see the sun texture. I also decided to scale the orbit points up a bit, because it looks just better in my opinion. Now I had to make the cinematic video. I did that using a sequencer, which allowed me to place a camera in 2 different positions, and Unreal Engine automatically smoothly moves the camera from one position to the other. I spent a while tinkering around with this, and eventually I got something that I was somewhat happy with. It isn't a cinematic masterpiece, but that wasn't the goal of this project, so I'm okay with it. I pressed render and this is what I got. It isn't the highest quality ever, but I probably just didn't use the right settings. But I am very pleased with it. And finally, after one very intensive week, I finished this project. If you guys enjoyed the video, please consider leaving a like and subscribing, that would help me very much. And let me know in the comments what you guys want to see in the next video, because I got some ideas, but maybe yours are better.